So welcome back guys to our second video on the blockchain basics. So if you are watching this video for the first time, I recommend you watch our previous video because that is where we started, so that there will be a consistent knowledge as we proceed. So in today's video we are going to continue from our last class, and today we are going to be talking more about the block. Now in the last class we were able to introduce the definition of a blockchain, and we were able to define blockchain as a distributed digital ledger that is continuously growing in a list called blocks, right? So, and it is a decentralized and is controlled by multiple nodes. So in our last class too, we were able to identify that Bitcoin was the first blockchain ever that existed in the year 2008. So in today's class, let's talk more about this block. So these are the properties of a blockchain. It is a distributed ledger. It is decentralized. It means that it's not a single entity control. It is immutable. Once data is written to the blockchain, it cannot be changed. It is transparent in the sense that it is public. So every transaction on the blockchain is transparent, it's public. Everybody can see everything in blockchain. All right, so all the transaction, everything is open. So that's why it's very transparent. It cannot be changed. Everybody is seeing it. All right, so it is trustless. You do not need to trust any individual party. So that is what Ethereum actually solves, right? You just have to trust it because it is a smart contract and it cannot be altered. It does not seek permission for anyone. It treats everybody equally. All right, so now what happens under the hood? That's what we are going to discuss today. Let's understand what happens in a block. So remember, from our definition, we say that a blockchain is a continuously growing list of records called block. So it means that in blockchain, there are a list of blocks that are continuously growing. So the first block ever existed in blockchain. Now, when I mean blockchain, I'm talking about Ethereum, because Ethereum is our blockchain that we are going to be working with throughout this course. Now, in Ethereum, the first block that ever existed was known as Genesis block. So, and the index is B0. All right, so this block is categorized or divided into two. We have the block head and the block body. All right, now let's talk about the block body. The transaction you make every day on blockchain are saved in the block body. You simply send Bob $500. That's a transaction. It's saved in the block body. So any transaction that happens on the blockchain is saved here. So this T1 serves as first transaction that you made, second transaction, third transaction, fourth, fifth, sixth, seventh, and eighth transaction. Now in our last class, I introduced something known as hash. So let me show that again. I told you that hash is a one-way algorithm, in the sense that anything you put, anything that is hash, cannot be decrypted, unlike encoding. So in cryptography, hashing is a one-way algorithm. So this particular hash, there is no algorithm that can turn this hash into one back. All right, so the idea is that they are not saving the actual input, rather they are saving the hash of that input. So nobody actually knows that input, so nobody can unchange that. All right, so everything on blockchain are hashed. In Web2, they uses encoding, like WhatsApp using encoding, whereby you send message, it's being encrypted, and it can be decrypted, and you see the actual message. But in hash, Levi, there is no algorithm in this world that you give this hash to produce Levi. Never. That's the idea of hash. So this is what blockchain uses under the hood. And Ethereum uses Kashak 256. It uses this Kashak 256. Bitcoin uses SHA 256. SHA 256. Now, back to our analysis. So now all these transactions are being hashed. That is what TH means. Transaction hash. So this is a hash, this is a hash, this is a hash, this is a hash. Now, this hash and this hash are combined together to produce another hash known as hash 1. So transaction 2 and 3 are also hashed together to produce another hash. Transaction 5 and transaction 6, both of them are hashed individually. Then the hash are brought together and it is also hashed to produce hash 1. Transaction 7 and transaction 8 are hashed individually. Then both of them also come together and it was hashed to also produce this hash. So now, this output that you're having is a hashed. That is, this particular one now, this first one, is the output of two transactions that was combined together, the hash of two transactions that was combined together. Now, these two also are combined together again to produce another hash. So you can see how these things are linked together. So these two now, they are combined to produce this hash again. These two again too are also hashed to produce this hash. Then you can now see we now have these two hash now existing in this whole block. Now, two of them are hashed to produce what is known as Merkle root or transaction hash. So Merkle root is the output of all the hash in the block body. All right. Now, if this particular course is the basis of blockchain, but if you are so much interested in how to develop this kind of algorithm where you write the code individually, we also have a mentorship class where you register and I will take you on a live class. We are going to program this particular algorithm one after the other until we produce this hash, so that you deeply understand what is going on under the hood of blockchain. We are going to write the code. I will guide you one-on-one. You understand all the concepts. You got to know what is going on. So, but for the basis of this course, you have to follow me along so that you understand the concept, right? So now it produces a Merkle root, or known as transaction hash. Now this Merkle root is being added to the block head or block header. You can see now the Merkle root exists in the block header. Remember, this is the first block. So other things that exist in the head comes here. So all these things are hashed. Remember, all of them are in a hash format. To all of them also produces a one hash known as block hash. So this block hash serves as the entire hash for this block, and it is passed on to it is passed on to the next block. So the next block take in the previous block, and that's what is known as previous hash, or some documentation call it parent hash, because this guy is the parent to this guy. So this guy will not exist if this guy was not here. So that's why it's called parent hash. All right. So now this B1 block 1 also has its own transaction that happens, and it also follows the same process, just like the first one. So many transactions, they are hashed and they are joined together to produce this hash. This one joined together to produce this hash. Then two of them join together to produce this hash, and at the end we have a make root. So the make root is also added to the block head. Now in this case we now have a previous hash. So this first one do not have previous hash because it was the first block that ever existed. Are you following? So but this block now has a previous hash. So this hash now, all of them are now joined together to produce the block hash for this block. So that block hash is also passed on to the next block. So this is how this is what it means that when they say that a blockchain is a connected chain. They are connected all together, so it cannot be altered. So for me to know this T1 in this Genesis block, for me to know, for a hacker to actually know what the information in this T1, which is not even possible, he has to, this block hash, he has to fight this block hash and get the result, then also come here, unhash this guy, unhash these guys, unhash these guys, unhash these guys, come over to this place, unhash before it gets to this one, which is never possible. So I'm kind of trying to make you understand why they say that blockchain is immutable and it's transparent. Everybody can see all these transactions, not the transaction itself, but the hash of the transactions, not the actual input, but they can see the hash of this transaction and what happened in that transaction, but nobody can hash it, or can hash it, right? So this is how blockchain connects. Now in my analysis, in our illustration, I am in block 4, but currently let's refresh this site to see the current block we have on Ethereum. Now this is 12 seconds ago, because this block degenerates every 12 seconds. So this is you can see this is the block. How many is this? 1 2 3 1 2 3. So this is 25,723,026 block. You can see the amount of block that have been generated as at this time. If I say refresh it again, it will update, because it updates every 12 seconds. So if I open this first block, you see that inside this block there are 212 transactions. All right, so you can see what I'm trying to explain to you, that a block contains many transactions. All right, and each transaction are hashed independently, then they are now combined together to hash for them to produce. So you can see that let me show you, let me see, propose, click for more. Yeah, see parent hash. guys, you can see the parent hash, the hash before this one. This is the parent hash, all right, and this is the hash of this current block. So if I refresh this, there's another block that have formed. So basically, this is the knowledge that you have to understand at this level. As we proceed, we are going to explore more, but for the time being, I would advise you guys to take a look at this site, etherscan.io. Go to etherscan.io. When you get there, just open any block and try to understand what is inside. Try to understand all these concepts so that when we reach here, it will be easier for you to understand. But with this point, I hope you understand what is going on, how blockchain are being are handling their transaction under the hood. All right, so yeah, this is the end of this class, and I'll see you in the next class. Thank you.